All right, thank you for coming. Thanks again to Sean for helping put this on. And thanks again to the Celonis folks for helping us do this as well. We are lenses.io. We're a part of Celonis, so that's how we get to use their really swank offices. It's quite a perk. Thank you all for coming out. So we're going to get going here, but I wanted to introduce, starting with myself. My name is Drew Etzel. The O is silent in my last name. Don't ask me why. You'll have to ask my great-grandfather. He might know. And then we have Adamos, and he is the head of product here at Lenses, and we have Carlos, who is one of our developers here at Lenses, and we're going to be talking about our K2K replicator, our Kafka replication product that we have been working on and we're super proud of. And so we want to tell you a little bit more about our thought process on building this product and how it all went together. And then I'm going to show you a demo of the very, very alpha version that we have going right now. But then we will also be able to have preview signups later as well. But I don't want to spend too much time yakking. I want to pass the mic over here to Adamos to start things out. But if you do have a question, you can wait till the end, or you're more than welcome to shoot your hand up in the middle, and we will try to stop and answer questions in the middle. I know sometimes if you wait till the end, you forget your question, or so feel free to shoot your hand up and ask your question in the middle. We don't mind. And without any further ado, let me hand the mic over here to Adamos.
Thank you very much, Drew. I was just joking around with Carlos that it's funny how a product guy and a developer guy get to stay away from the demo, and instead we have our DevRel guy actually try it out, and if it fails, it fails. So we're pretty safe on this side today. Okay, so we're going to talk all about mirroring topics from one Kafka to another Kafka. But before we do, I just want to ask the classic question, who uses Kafka today? All right, that's kind of like a bit more than 50%. Good. And in what you do, which one of you actually have more than one Kafka cluster in their production? Okay, so half of that. Very interesting. So we can talk more about maybe why that's the case. So today, we're all about that case. Basically, people that for some reason they end up having more than one Kafka cluster, and for some reason they need to share data from that cluster to the other cluster. But first of all, let's talk why would we ever need to solve this issue of mirroring Kafka topics from one side to another again? Isn't this already solved? And before we do that, maybe we should check why would people want to share topics from one Kafka to another in the first place? Well, what's the whole point? I thought that Kafka is horizontally scalable and resilient. Why would you need to do that? And before we do that, I guess, one more question for you guys, since we're building this thing and we're interested in performance. In your production clusters, do you ever exceed that big number over there? Have you ever had more than 50K partitions across your entire cluster? Nice. How much?
We didn't really bother to count.
Are we talking like another zero there or more?
No. I don't want to show off here. Probably something around, in the region of
50 to 100? Yeah. With replicas included or without? Okay, so the total number. Yeah. Nice. Good, because that's kind of our upper thing where we're designing it, so I wanted to check. Okay, so back to this question. Why would you ever want to replicate from cluster A to cluster B? Turns out there are a few fundamental reasons why, and we've discovered this talking to our customers and users. The classic scenario, your kind of like vanilla case, is because you need a plan B. Basically, if your cluster goes down, and I know it's resilient and it's not supposed to, but it still can. And when it goes down, usually you need a plan B. So DR, disaster recovery, is the classic scenario. And fundamentally, it means that You need a way so that you constantly pump data from your topics over here to your topics over there to the DR, so that if things go bad, you can get your applications to easily shift from there to the other side, and then somehow magically resume, and all is well. You didn't lose anything. There's one little trick here, apart from making sure that the data is constantly pumped from one side to another, and hopefully exactly once, because if you keep at least once, means you might end up with duplicates on the other side. If you end up with duplicates, then your apps need to make sure that they can deal with them. Otherwise, when you switch over, you might end up having double or triple. So you're putting the effort on the developers. So it's good to have exactly once. But the other tricky thing is that when you move the apps over to the other side, the offsets, as in the positionings of your other topics, might be different. So you need a way to translate wherever the apps had left off to what that looks like on the other side. And this is all the consumer translation. So that's kind of like of the gotchas in this scenario. But this is your classic scenario. Number 2, kind of the same, but with a different spin. You can think of it as a one-off. So you still need to move things from one side to another, but in this case, it's a one-off because you're migrating your Kafka cluster. We've heard so many times of people, they started off on-prem, and now they want to modernize and they want to move to a cloud. Or maybe they were in a cloud, and turns out they're locked in and it's too pricey, and they picked up another cloud that's cheaper. So they want to now move all the way there. Or maybe they have sort of legal reasons why cloud is no longer good for them, so actually they need to move back to on-prem. No matter the reason, a migration is a thing. The difference here is that it's one-off. Like, you've done it once, and then you don't need to do it again. But you cannot stop the world. This is sort of your classic way of thinking, right? I just stop, move everything, and then restart again. Because this is most likely running your live business, you want to continuously start pumping data to there, and then gradually move applications to the other side until they're all moved, and then you can turn this off. So because you're also moving not just data but the apps, you still have the same problem that you need to translate the offsets to the other side too. And that's how I think this is kind of the same but different. So this is your one-off. Now we're getting into more interesting ones that maybe they don't come immediately to mind. This is what we call the extract one. And the classic typical scenario is when you need to safely test or simulate something that happened in production. Many people start by just literally hitting production, but more and more we see people that not liking this. Maybe it's because of performance, maybe they don't have the right access, and that's okay. So many people, what they end up doing is they want to extract a particular topic or a few, or maybe slithers of a topic, particular sections of the topic that represent something that happened, and push it down to a lower tier environment, like a staging environment, where at that point you have full freedom to do whatever you want. You can experiment, you can try stuff out. But if you notice here, there's this little bubble because it indicates that, well, moving stuff from production to staging, that sounds like a bad idea because you might have sensitive data, things you're not allowed to touch. So if you're going to mirror a topic to the other side, you better have a way of masking things that you're not supposed to access or filtering things completely out. So this is an interesting case where just sort of blind mirroring doesn't work. It needs to be able to do a little bit more, but it's still valid. And then the final thing, which is again a different take on that one, is the general thing around sharing. And piggybacking from the previous talk, the whole concept of data mesh is the idea that somebody owns their data and they manage to control how it's being shared to the outside world. So what we're seeing is if you take this data mesh concept down a few hops, eventually you see that potentially different departments or different domains own their Kafka infrastructure as well. So they want to selectively share bits and pieces of their streams to another domain Kafka. And again, at that point, you want to have full control of how much of it do I share. Do I share all of it if it's sensitive? Do I need to mask some stuff? So this is more of the generic version of sharing things. And it could happen within a company, across domains, or between companies. You're working with a partner. Maybe you're in the EU, they are in the US, and you want, again, to choose certain things to share. So overall, these are the kind of 4 big patterns when it comes to why people end up needing to mirror or replicate topics across clusters. Right, so now we've established that, yeah, this is a need. Well, there are things on offer now. So let's take a look at them. And we've had a look at them, and yeah, they're pretty good, but usually the more you look at them, the type of answer is, yeah, they can do, but. So we're gonna have a look at how that pans out. And it was not easy to try and compare these things because they're pretty complex. So we came up with this very patent-pending, completely proprietary thing called the matrix that has 9 blobs, and then we're going to use 3, you can't tell that there are 3 colors, to indicate whether they're doing it great, whether they're pretty okay, or not so great. So first of all, we're going to start with the de facto standard, which is what's called the Mirror Maker 2. It's part of the Apache Kafka, so it's part of the base, well, the code base. And that has some great things because it's free, it's open source, it's out there. And as you can see, it does some good things really well. Even now, it even managed to do exactly once recently, which is really good, so you don't have to deal with duplicates. It's agnostic, which means you can pick your own Kafka flavor, whether it be it Red Panda, Apache, Confluent, doesn't matter. It works everywhere. And of course, it's open. If you squint your eyes, maybe you can do a little bit here. So you could do a little bit of filtering if you really know your SMTs and Kafka Connect, and you can do a little bit of routing to say this, put it over there. But it's not really powerful at that. Now, the buts is, first of all, it's not easy to use. If you know Kafka Connect and you're really good at connectors, okay, you can sort of ramp up, but even then it's complicated. Otherwise, if you're starting from scratch, it's not easy. You don't get support with it. It's the unfortunate side of a purely open source model. It's not Kubernetes native, so we're seeing a lot of adoption in the microservice world of Dockerizing everything, shipping it to Kubernetes. Kafka Connect was great for Kafka, but unfortunately, it's another way of doing resource management. So if you try to put Kafka Connect on top of Kubernetes, now you have basically 2 problems, and they clash with each other. So it's a bit quirky. And finally, yeah, you gotta squint really your eyes to say that this does transformations and filtering well. What's next? Well, next we're gonna visit 2 offerings, which is basically a take on Mirror Maker 2 that was taken by a vendor and closed off and given some bells and whistles on top. So Confluent took Mirror Maker 2, closed it off, called it a replicator, and then tried to offer something great with it. Fundamentally, support. So with replicator, you get MM2 with commercial support, which means that if things go pear-shaped, you have somebody to call. That's good. It's still agnostic, so you don't have to use Confluent clusters, even though they'll really try to get you to do that. But you can use any Kafka you want. But because it's based on MM2, it still has the same issues. And I believe they still use an older version of MM2, so you actually don't get exactly once still. And I think it's because they're actually ramping off Confluent Replicator. They're kind of not maintaining it as much. And there is a reason why. I'll tell you in a sec. So that's Confluent Replicator. Oh, and it's expensive and still hard to use. Right. The same take, but different, is now AWS doing that. So they took MM2 and they packaged it, and fundamentally their angle is that it's SaaS. It's fully managed, which hopefully, gets some of this Kafka connectness and infrastructure pain out of the way. Great. They are AWS, so they offered some support. If you've experienced AWS, I guess you've formed opinions about what support really means at AWS, but sort of. You can say it's easy because it's AWS, so sort of easy. And of course, you get the basic ops that you get with any AWS service, so that's good. But what is interesting is that it's vendor specific. So your source, where you're getting the data, can be any Kafka, but your target always needs to be AWS MSK. So you're a bit limited there. Again, I think they took an older MM2, so again, still no exactly ones, and they've locked down the things that you could do with the traditional MM2 through Kafka Connect. So you can't do any transformations, you can't do any data routing. So it's much more limited at the benefit of having it as a SaaS. Last but not least, the different horse in this game is Confluent cluster linking. This is really interesting because they took a completely different approach. Rather than trying to copy MM2 with something on top or around, they approached the problem from a completely new or different angle. Basically, the Kafka itself knows how to send data to another Kafka. So it's native replication across Kafkas. So what they try to do is do just one thing and one thing really well, which is basically exactly once copying of one message here, over there, including the consumer offsets. And they do that really well. But, well, it only works with Confluent Cloud. So if you have Apache Kafka anywhere else, unfortunately, you're out of luck. It is easy, and of course, it comes fully managed, which is great. You get the guarantee of exactly once, and you do get support. But you don't get any of the other flexibility. You don't have no way of routing stuff. You have no way of transforming or filtering things. There's no openness. And of course, it's expensive because it's consumption-based. But it does one thing really, really well. So with that in mind, hopefully you kind of get the idea that you have options out there, but they all kind of do something, but not everything. They hit a few points and miss others. So when we approached this, talking to customers, we really tried hard to do this differently. So how did we do that? Well, first, we were fortunate because we could learn from all these guys. I mean, if these guys weren't there, probably would have repeated a lot of what they did. So we're very thankful that these products already exist. What we did was not try to base it on MM2, which is based on Kafka Connect, but really try to design something that is for more the modern approach, which is Kubernetes first. So what you'll find is K2K is just a Docker image that is fully capable of just throwing it into a Kubernetes cluster and scaling it. It does come with your exactly ones, and it is fully agnostic. So you can bring in any Kafka that you want, be it managed on-prem, vanilla or not. We have a control plane on top, which means it's easy to set up, and hopefully you'll get to see a sneak peek of it today. So you don't have to worry that, okay, I'm getting something that is powerful, but it's extremely hard to use. So it's easy. And it comes with optional support. So we want to try and find the right balance between being open and offering that peace of mind. So the idea that we're going on now is we want to offer a free community edition so that you're free to use, you don't have to talk to us ever. But if that goes well and you are sort of nervous about running in production, you can always come back to us and we can talk about support. And I'm putting this on not a totally red one because we are also considering whether it's worth open sourcing it. And that's where I would love to get your feedback if that's something that's important to you. But yeah, so hopefully you get to see that. Oh, and did I mention that we're doing a great job here at having a lot of flexibility of how you route topics in whatever way you want, and also how you can filter and obfuscate stuff. So we're doing a lot of work there. So if we were to take a picture is worth 1,000 words type of look, hopefully you get to see that there's a lot more red there, a lot less red on the other side, which is hopefully a good thing. In this case, red is good. And I linked those three because they're all fundamentally based on MM2. Right, so I've talked a lot, but you've seen nothing. So how about we show you something? So I'll switch it over to Drew.
All right, let's hope I can get my laptop to pair with the monitor. Say a little monitor prayer.
Let's pray to the gods.
Yes. It's doing something. It's thinking. Ah, that's good. All right. I shouldn't be too that crazy surprised. All right. Not me. Okay, so let's start off here at the very top. And let's pray to the internet gods as well that we don't lose lose internet connectivity. But so I'm going to show you a sort of the very alpha version of our K2K, but it starts in our lovely Lenses UI. So this is Lenses 6.0 multi-Kafka. It's designed around having multiple Kafka clusters. Now, I realize I only have 3 here, but you know, that's a lot when you think about it if you're going to manage Kafka clusters. So
Sales pitch whatsoever.
Oh, sorry. So you see here, I've got I've got a Netherlands production cluster and I've got a UK staging cluster. So I just had some edge sensors installed and they are streaming really nicely into my production cluster here. What I want to do is I want to copy that edge sensor data. There's nothing sensitive here. It's just the temperatures in the factory, or it's not sensitive stuff. So don't panic. But I'm going to copy that from my Netherlands production cluster down here to my UK staging cluster. So come in here to topics. Now this is all the topics I have across all my clusters. So let me search here for edge. There's my edge sensor data. It's in my Netherlands production cluster, and it is Avro schema. So it's got an Avro schema.
By the way, who uses schema registry today? Okay, Avro mainly or protobuf as well? Mostly Avro? Cool.
I always thought protobuf just was like before you go to the gym. Ha ha. All right, replicate topic. Tip your waitress, I'll be here all week. All right, so I came in here, you saw I clicked on that and I clicked on replicate topic. Where did my mouse go? There we go. So I've got my source environment, I've got the name of my topic, then I just picked my target environment, UK staging. Then I'm going to click on Go to Configuration. Now, this brings up the replication configuration. This is very alpha, so we're going to add more features in here, like if you're going to be setting up filters, routing, all those magical things we were talking about. You could set these up and configure them here. Where'd my mouse go? There it is. All right. Let me, I can give it a better name though, so I could call it, well, edge sensors replication is fine. Or you can make it fix it like that. I can actually change the topic here. I could maybe add like underscore stage. So we know that, this one is in staging. Just, I can create my destination topic there. Then I'm going to click on Save and Deploy. All right. Great. So that brings up this screen. This is our replication screen. So you see all of the other information here. So what's actually happened here is it's currently spinning up that container that Damos was talking about. And it's going to start consuming from the source and replicating it to the destination. I can come over here and see, the different configurations. I can actually see the configuration as code. I can come over here and see the metrics, of the replicating topics. And it might take a little while, but if I come here, search for edge. Nope, not yet. It'll come. Give it a second. But once it does come up here, we'll be able to see that it's actually replicated there it is, edge sensor staging. Hey, you can see here, whoops, oh, let's go forward again. If I come in here, I can see, all right, look, there's my sensor data, there's my temperature data. I can come over here, there's my schema. Look, I've replicated the schema and everything. So, ta-da! I now have a copy of my temperature data from the edge in my staging server or staging cluster. So now, we can test it. We can do, different kinds of tests and do whatever you do in staging. So, any questions on the demo?
Is it real?
It is real. It is very alpha. There's a lot more bells and whistles we need to install, but we wanted to show you a couple of things. Yes?
Can you define it in YAML?
Or do you have to click offset?
You will be able to, yes. It's still ClickOps right now for this part. We kind of went back and forth because you could go and, you could do this in YAML right now, but I didn't really want to be YAMLing live on stage. Not yet anyway. But yes, that is the ultimate goal. More questions? Yes.
Going back to the chart he presented where he compared K2K with other mirroring software, and up on the top of my head, I was thinking, what if other mirroring to sort of catch up with you guys, maybe 60 to 50% more? I mean, how do K2K plan to stand out? I don't know if you understand.
Plan to start out?
Plan to stand out? So vendor agnostic, so we'll copy whatever. We don't care as long as it works with the Kafka API, we will copy it. Lovely UI, so you don't have to stand up on a stage in YAML. Technical support, I think, are kind of the three big ones. What am I missing, Adamos?
Yeah. So the biggest thing is that we want to offer the most complete way that you do replication. So we want to offer a thing that is Kubernetes native, which means that you control the infrastructure, and somehow we offer you a control plane that you can do things very easily. So you can think of, I don't know if you've heard of the concept of GitOps, where you just declare your YAML, and something out there magically takes care of deploying, managing it, permissions, governance. All that stuff is the control plane that we're showing here today, and we're just showing a simple example. There's tons of stuff around details on how you transform things, how you filter things that none of the others support, or how you route things. You can imagine that you can have blue topics on your source and you want to just say, can you please rename them to red topics? You'll find that even that is not easily done today. So there's a lot of in practice capabilities that are not on offer today. And you basically have to choose either you go for an open source thing that you have to fully manage by yourself without support and you need to know Kafka Connect, or you go for a managed or vendor-specific thing that is either extremely limited or you're vendor locked in on your Kafka. So we want to tackle both, plus additional capabilities. And because we pair this with our dev experience, which is Lenses, you'll get out-of-the-box intelligent alerting, you'll get permissions so that you don't have to, as an SRE, worry about replicating stuff. You can basically tell each team, here you go. Go ahead and replicate. And they will never be able to do the wrong thing because they will only be able to replicate the topics they own. So it's the full package in a way, rather than just the tiny little engine that replicates. I don't know if that makes sense. Nice, nice. And I guess what we showed here, I guess it looks pretty simple. I guess, there's data on the other side, one side, we send it to another side. But there's a reason why Drew pointed to the screen, because we mentioned that this is not just string or JSON data, this is Avro data, which means that the data is encoded and it needs to work with schema registry, which registers the Avros. Now, what we didn't say is that those two Kafkas don't use the same schema registry. They actually use different schema registries. So how on earth can you actually replicate Avro data from one side to another, yet still be able to keep those two schema registries at peace? And with that,
was a nice
yeah.
Well done.
The cliffhanger. Let's switch.
I need a laptop with.
One laptop switch, please.
Yeah. I feel like doing karaoke all of a sudden.
Yeah. My heart will go on.
Yeah, it will. It will. Hopefully it will.
Let's see. Did it work? Yeah. So now we're going techie, basically.
Okay. Is this my voice being? Yeah, all good.
Everybody, welcome Carlos.
Yeah. Well, thank you. Thank you. Good evening, everyone. I'm Carlos, software engineer at Lenses, as said before. And yeah, so we were seeing just now how K2K is able to transform data or to move data and kind of move schemas from one cluster to the other. But we haven't really given you any kind of technical background as to how it does that. And my job today will be to give you a little bit of that. So we're going to be looking at more exactly to how schemas are mapped, so how we move a schema from one place to the other and how we make sure that the schemas will work in the target cluster. But before we look into the behavior, I kind of want to give you a little bit of a little bit of context so that we can understand what's going on. So the first thing I wanted to go over is the data model of the schema registry. So this is just a very simplified, dumbed-down version of a schema registry. The key takeaways is we're really only interested in 3 different entities from the schema model, from the schema registry. That would be the schema, the version, and the subject. So the schema is kind of your data shape definition. So we'll have all the fields you have on your data, as well as the data types of that payload. And then version is kind of used to connect the schema to a subject. And then the subject is kind of this entity that you have that kind of changes shape over time. And so just to give you a quick example, here I have this this user subject. Initially, we only cared about the name for the user, so we had the first version of the user entity to have only one single field. Over time, we kind of decided that surname was important, so we kind of registered a new version for the surname. Another thing that's worth highlighting here is that the schema registry is kind of expected to not duplicate schemas. So if you have like a totally different entity that uses the exact same schema for some reason, rather than duplicating it, it will just reference the same schema that was previously registered. So in this case, the GB user, which is separate from the user, they both kind of link to the same schema. And yeah, I guess to summarize this, the idea is that we have subjects connected to multiple versions, and then we have versions connected to a single schema, the other way around, schema connected to multiple versions connected to a single subject. And so if we forget about versions for a quick second, we have kind of a many-to-many relationship here, where a subject is connected to many schemas, and schemas are connected to many subjects. This will be relevant a little bit later. So we looked at the schema registry, and the next thing to look at is the actual data in Kafka. And I'm not really interested, for the purpose of this talk, in giving a big breakdown of everything that exists within the record in Kafka. So here at the bottom, I'm kind of just representing one of the facets. So usually you'd have headers, you have some metadata, and there's a key, there's a value. Let's imagine that this is the value facet of the Kafka record, and whatever I'm going to tell you for the value also works for the key. And so so when you're using a schema registry, the idea is that, sorry, just a second. So when you're using schema registry, the idea is that your payload isn't actually just a blob of bytes. There's actually a little bit of structure before you actually get to your record. The idea is that we always have a magic byte, which is always set to 0. Then there's 4 bytes. Those encode an integer. We'll see in a second what that is. And only after this do you actually get your full record payload. So those 4 bytes, what they have is an ID. So they have an integer, which could be 23, 47, any kind of integer. And what you can do with that is you can go to the schema registry, and you can fetch the schema for that specific record. So there's an endpoint in the schema registry, and you fetch that schema by ID. And having that schema is more or less enough for you to be able to deserialize your record. And so for the purposes of K2K, however, we're interested not only in the schema, but we're also interested in the subject. So we kind of have to resolve that whole relationship. But if you remember what I said before, the subject might be connected to multiple schemas, and the schema might be connected to multiple subjects. So there isn't a way to reliably go from a schema all the way to subject. Yeah, there isn't one. So long story short, to kind of resolve this whole thing, what we do is we kind of have to rely on the user, and the user through config to kind of tell us what subject strategy they use. So usually there's 3 main strategies. There will be topic facet, which means that you kind of name your subject based on the topic the record is in. So you'll have, if the topic is named transactions, there will be transaction-value and transactions-key. If there is, so that's one possibility. Then there's record name, so that means you kind of fetch the schema. You look at the top-level record name for that schema, and then your subject is named after that. And then the last one is kind of a mix of 2. So you kind of take the record name, and you take the topic name, and you kind of combine them, and that's your subject. And so with this extra bit of information, now we're able to go from this 4 bytes here to understanding what schema is associated with this record and which subject is associated with this record. And I guess with that information, we're kind of in a place where we can actually look at K2K working and try to understand what it does. So here at the bottom, I kind of have this simplified representation again of a topic. So I've already separated the different things. So we have the magic byte, we have the schema ID, and then we have the payload itself, which doesn't really matter. And our goal is to kind of move this data to the left side, while also moving the schemas that we see at the top. And so the way K2K will work is it will work record by record. Like in reality, we'll actually batch things, but to simplify our presentation, let's assume it goes 1 record at a time. So we look at the first record. The first thing we do is kind of take a look at that schema ID. We understand that that's a 4, so we can identify there at the top what's the schema. Then we already know that we're using the transaction topic, so that means that we also know what the subject is. And so we can now take that. We can now take the subject and the schema, and we can register it there on the left side. And I guess the first thing we could do is to just move the record over. But if we were to do that, we would actually get a problem. And the problem is that the schema ID we copied is schema ID 4. But when we register schemas on the target side, we don't actually control what the IDs will be. So in this case, maybe if you can spot it, but if you don't, the same schema we had here was registered under ID 1 on the left side. And so what we have to do to make sure that whoever is looking at the left side is able to resolve the schema correctly is change the schema ID that we copy so that it now references the correct identifier. And so we kind of have to keep track of these mappings between schemas so that we can adapt correctly the payloads from one topic to the other. So we keep on going. We go to our second record. We again get the schema identifier. We retrieve the schema associated with it from the schema registry. We copy it over, and we copy the record with the appropriate mappings. And we keep on going to the third one. Let's see if this one goes through. We again get the schema from the schema registry. We know what the subject is, even though it's connected to 2 subjects. We copy it over, and we get a problem. So the reason, to be fair, this could have happened before when you were registering the second one, but the reason why we had this, or that we could have this issue here, is that if you notice, we kind of register things out of order, right? So we kind of register version 1, then version 3, and then version 2. And then what can happen is that because we're registering things out of order, and the compatibility level is defined at the entity level, it might happen that I guess V2 might be backwards compatible with V1 and V3 with V2, but then if we swap these, this relationship might no longer hold. And so to avoid this and to kind of work around this limitation, we actually do something slightly different. So rather than just copying schemas one by one as we find them, what we do is we kind of identify the whole subject, and then we copy over the subject as a whole. And then we obviously keep track of all the mappings between the representations. And then from that moment on, we can just look up those mappings, and we can copy over the things from one side to the other. And yeah, so that's kind of how we do schema mappings, and that's kind of the approach. The last thing that I wanted to mention is subjects and versions will sometimes reference other subjects and versions. And so when we're copying things over, we also kind of resolve the dependencies first, and we copy over the dependencies, and then only then copy the top level subject. And so the last thing that I wanted to show you is actually related with a feature that K2K is able to provide, and that is we're kind of able to map topics. So you kind of can take, like for instance here, we're taking a transaction topic and we're moving the data to a topic named backup.transaction. And the problem with that is before we kind of mentioned that subject strategies, so the name, the reason why we give transaction-value that name, depend on the topic name where the data is. And so in those situations, what we do is, because we know what the strategy is and we know the source information, rather than copying the subject as transaction-value, we copy the subject as backup.transaction-value. And this would work even if that was called, I don't know, users or any kind of name. And yeah, so yeah, then we'd copy the record over, and that would kind of be it. And so yeah, to wrap things up, this is kind of the strategy we use in K2K when we do schema mappings. So it's format agnostic, because we don't really care if the data is Avro or protobuf. We're just able to kind of treat schemas as this blob that gets moved around. Then we kind of have a schema registry is idempotent, so it means that if multiple instances are trying to register the same schemas, they will just get the previously given responses. And so that means that we can have multiple Kafka to Kafka instances. If 2 or 3 or any number try to kind of register the same schema at the same time, then you won't really get a clash. You'll just get, they will all get the same responses back. They will apply the same mapping, so there won't be any kind of issues. And also because of the way things are set up, we don't really need to care too much. Like once you do the first moving of data, if you then register new schemas, those will just show up as a cache miss. So we'll try to resolve the mapping. That means it's not there. That just means we need to import whatever is missing to the target, to the destination. And then obviously, like not everyone uses schema registry. So that means that sometimes, so it actually comes disabled by default, but we are able to toggle it on and on with a simple flag. And yeah, I think that's it. I'll pass it to Adamos for the finalization, or should we do questions first?
Yeah, we could do questions now. Thanks, Carlos. But hopefully, yeah, what you saw here is that things might look simple at the very top, but when you start adding all the bits and pieces that you end up using on your actual day-to-day with Kafka, things get very complicated. And we talked about what's unique about K2K. This is pretty unique. So none of the others actually do this, which means that they work as long as you have the same schema registry or you don't use schema registry at all. And it's funny because many people just start with JSON and they say, oh, I'm fine with JSON. What can go wrong? And as soon as they start adding a field to their messages, then they realize, oh. and then they have to move the schema registry, basically having some control of how your structures evolve. So hopefully what you saw here is pretty cool. I think we're pretty excited about it, and hopefully it also shows that the devil's in the details when it comes to actually trying to do something really well, even if it sounds simple, such as mirroring topics from A to B. But that's not all, and I guess then we can take questions. So, yeah.
Go for it.
I just wanted to say that this is just a small slice of what it takes to replicate topics. And let's say this is episode 1. So we're very much active on all these things. So I would be very interested to see which one you'd be interested in hearing about next, because we can talk about how did we do automatic Kubernetes deployment, or how did we do auto-scaling, or how are we doing exactly once delivery? What are thoughts about doing everything as code with GitHub, so you don't have to worry of how this thing gets deployed, or when you're changing things in YAML and it's all magic. We talked a lot about filtering and obfuscation. We didn't show it today. How are we going to do that? And finally, data routing. How can we sort of say all blue things go to red, or pick up this star and move it over there, or explicit mapping? So these are all things that we're working on. And yeah, have a think about, because we'd love to hear which one you'd want to hear next. And yeah, and that's us. In general, please give us feedback. This is very much an active development. We want it to be something that's useful to everyone. Yeah, and open for questions, guys. Thank you. Eric.
You want to go first?
Oh, sorry.
2 questions.
Yeah, please.
One is when you showed on the first part of the demo that you started mirroring one topic, you deployed something
Mm-hmm.
that was mirroring one topic. So how do you scale that if you have to mirror 50,000 topics?
Very good. Shall I try and take it, or I can try and take it? So there are 2 aspects of it. One is the experience itself, I guess, if you're going to UI it, which we can talk about that. The YAML itself should cater for it. So ideally, you'd want to just put a star if you want to replicate the whole cluster. And then the whole aspect is, how do you scale this? So what we're trying to leverage here, and probably if we want to go deeper, Carlos can back me up, is we're trying to leverage all the good stuff that comes out of the box with Kafka. So we use heavily the consumer group to balance load. But effectively, this is a Docker app that is horizontally scalable. So you basically just put more instances in it, and it all balances. And the idea is, because we offer this holistic approach to it, as in Lenses is capable of knowing what is your total number of partitions, actually the app can do that as well, it means that we can inform even Kubernetes on what is the upper bound of your scalability, which is the number of partitions. If your total number of partitions is 10,000, then you know that that's your max sort of upper bound on how much you can scale theoretically. You probably would never do that, fan out 10,000 pods, but that's your theoretical thing, because if you go above that, then you have consumers that are just lying there. And then what we're going to be working on is, what sort of metrics can we track to do some intelligent autoscaling? So we'll start with the basic Kubernetes one, which is kind of memory and CPU, but then we want to start tapping into things like throughput, ETA, to get more intelligent about when we choose to spin up and down. I don't know if that touches a bit on your, yeah?
And the second question is, it's easy to do exactly once in terms of replicating the records once. That's easy. But when you shift an application from cluster 1 to cluster 2, you normally have to account for the application to be able to reconsume records.
Yep.
Because you are not, I mean, with MirrorMake it's currently impossible to, you can do exactly once of the data, but not the data and the offsets. So you have to assume that some reconsumption once you move the application from source to class to target
Yep.
is necessary. Can you avoid that?
So that's something that we're actively investigating now. We want to tackle consumer offset translation, which is basically making sure that when you switch the application over, you know where you need to resume from. I believe MirrorMaker does at least once on the consumer offsets, but not exactly once. This is something that we are researching now, but we want to find a better solution to what's existing, for sure. And again, one of the powers of K2K is that it can work in tandem with lenses. And if you think that lenses is a control plane, there might be some insights that it can communicate to the replication process or even to the applications themselves, because lenses could automatically adjust those offsets for the applications. If, for example, it sees that, the earliest is this, but actually it needs to be shifted by one, it could potentially do this. But this is very much active right now. We don't have the solution yet. But yeah, very good question. Yeah?
Yeah, comments or questions, however you want. So the first one is, like in terms of like the matrix comparison that you've made, and you were talking about GitOps and running Kafka Connect and Mirror Maker in a Kubernetes environment. I beg to differ a bit because we use that heavily in Kubernetes with Strimzy. So the Strimzy operator takes a lot of the pain away with Kafka Connect and Mirror Maker management. We deploy that, otherwise we'd go crazy.
Yeah.
So I think it would be fair to add that to your comparison in that thing. And tied to that, I would absolutely love you guys to actually open source K2K. That would be great. And,
Yeah, it's good to hear.
Because I think that generally in our experience, we work also with a lot of companies like yours, right, that have added services. It's easier in terms of adoption on the enterprise, where we basically have the ability to run and trial the open source variant before we actually buy the actual commercial product with support and the whole shebang, right? So that would be really good. And if you do, let us know. Absolutely.
And so yeah, very, very fair comments. I think, yep, sorry, go ahead.
Because the real killer in K2K, I mean, there are lots of cool features, but you know, you can sort of replicate a bit of that behavior with all the other stuff. But the real cool thing that was really remarkable for me was the fact that you actually unsuck the schema registry experience with that replication into different schema registries. One of the reasons why we actually don't use schema registry that often, only when we have to, is because of that single instance problem across stages and clusters with different versions of fucking nightmare. It's actually awful. And the ability to actually align those across the replication is actually a really great feature. That's a real killer.
Nice, that's great to hear. Yeah, I think those are very valid points. I think the one thing to say is that, yeah, if you are on Strimzy, and again, you still need to have some experience with Kafka Connect. Actually, we are one of the biggest contributors of open source Kafka connectors. So we work a lot with Kafka Connect. What they don't tell you is about the memory footprint and the upfront TCO of running Kafka Connect and then on top of Kubernetes. So it's quite hungry. Whereas we wanted to have something that's really lean that you can then, it doesn't cost you to scale it. Because if you imagine you have to replicate thousands of partitions, it gets tough. And we've heard so many horror stories of people running Mirror Maker 2 on Kafka Connect, and it just works, except when it doesn't, and then we don't know what to do. So usually what we do is we restart everything, close our eyes, and hope it works. But yeah, I think if you know your Kafka Connect and you are on Strimzy, it's definitely a way in. And now on open source, we're very interested because we're trying to figure out what is it that makes people want an open source. Is it because they actually want to contribute? Is it because of safety that I can look into the code so nobody's lying? Because we are going to be offering a free community. So I guess the question is, what is it that you'd get by open sourcing it?
Yeah, well, if I may answer that question.
Yeah.
So for us, because we do that a lot. So the first one is, yes, looking at the code is super important. You actually, the black box stuff, I mean, I'm a bit older, I'm approaching 50, so I grew up with the enterprise landscape and Oracle and all that shit. We actually don't know what the fucking library does.
Yeah.
My French. So having the ability to look at the GitHub repository and understanding what it does, super crucial for adoption and understanding, right?
And maybe even troubleshooting, I guess, right?
And of course, you know, contributing and giving back, at least bug reports, super important in terms of community engagement, so 100%. The other important bit is we've seen, especially with like the business clients and enterprise clients, we've seen a shift in attitudes, right? But, like 20 years ago, they wouldn't buy something if it wasn't from a company with support. Now it is actually the opposite. They want to try out stuff for free, open source, and then buy the support. So it's a complete 180-degree turn on how they do things. And it's important when you bring in a new tool into into a client environment, especially for us as a consultancy, and we can tell them you can just try out this thing and see how it works, and then you buy this.
Yeah, yeah. No, it's good feedback. Thank you.
The third reason for open sourcing
Mm-hmm.
is that you buy from a vendor that offer maybe support from open source, but then if that vendor goes down, it's much more easy if the product is open source to find someone else who can take over.
Yeah, yeah, that's true. Well, yeah, in practice, I can challenge that because we've had experience like that. But yeah, in theory, at least you could. Yeah, it's fair comment.
We want you guys to succeed.
Yeah. No. We've had similar experience, and actually, yeah, it was hard for people to pick it up. But yeah, awesome. Thank you, guys. More questions?
Bit of an edge case, I guess, but I'm curious, like, if the source schema registry were to go down, that's something that is something you guys thought of, or?
Well, in general, that's a single point of failure in a sense, because at that point, no consumer of yours from that Kafka can go well unless it's cached already the schemas, right? Yeah. So you've got a bigger problem at that point, I guess. Yeah.
Other question is, if you wanted to use this outside of Kubernetes, is that possible?
It is a Docker container, so anything that can run a Docker, you're good to go.
Okay, in terms of, like,
I guess more than a Docker container is a Java application, so you can take it anywhere you want. As long as it runs Java, you can provide a config file. That's about all you need.
I suppose at scale, obviously, there's things that Kubernetes does that you need to figure out how to do. Is that an area of focus, or are most of your kind of scaling documentation and stuff going to be around Kubernetes?
So I guess if you want to scale up, I guess the easiest way, provided you're running Kubernetes, would be to just scale things through Kubernetes. The basic idea of K2K is that it's just a single app. So if you want to take it and deploy it in an EC2 instance and kind of scale it yourself, that's perfectly feasible. So whatever deployment method you need, that's just it's just put the application there, run it, provide it with the config, give it the connection to both source and target, and that's all you need.
Just a quick question. You said backup and restore, so we get a lot of questions around, if I delete it in my source cluster, is it going to get deleted in my target cluster? Have you solved that yet?
No, we haven't sorted that yet, but I imagine you need some flexibility, right? Different people want different things.
Solved that. It's by the guys in Netherlands, and they have snapshotting of their topics, and they can roll back data. I can show you the link.
Sure.
You basically have a full backup of your cluster at a point in time, so you can refer back to it.
Right.
Because obviously if you delete it in your source, it's going to get deleted in target, so it's not really a true backup.
But I guess that backup is not done on Kafka. Is it done on like object storage or something?
It's done on Kafka, but it's done based off, it's a Rust implementation of Kafka Connect.
Right.
It sends it to S3.
It sends it to S3. Right, yeah.
But you can consume it from S3.
Yeah.
Because they have the other side of it.
Yeah, so that's kind of a different use case where you're kind of archiving to S3, and we have a solution for that, and it's basically our S3 connector.
Okay.
So you can do that with our Kafka connector, and you can it's open source, so you can go ahead and do it. And the cool thing about that connector, I know I'm deviating a bit, is that it has its mirrored twin. So it comes with a sink and a source. So the way you sync it, the source can automatically understand because it comes with metadata. So you can literally just bring it back and rehydrate this Kafka or any other Kafka. So yeah, cool.
That's it. Brilliant.
Nice. Thank you, guys. Oh, come on. We got one more question. One more question.
One more.
So like, will it spin up like one instance for each topic, or we can use regular expression for hundreds of topics?
Yeah, you can use regular expressions. Yeah, and you have full flexibility where you want one instance of K2K that's horizontally scalable and takes many topics, or you can split. You can slice and dice as you want. All right. Thanks, guys. And yeah, think about the episodes. Oh, yeah.
I think we've got the room for maybe 15, 20 more minutes if you want to grab a beer or something, and then we'll head out. Thanks for everyone for coming tonight. It's been great.